Today, we make the leap from the humble pod to a self-healing deployment native to Kubernetes. If you aren't familiar with pods, check out the first video in the series here. Let's start with Replicasets. If you look at the template section, we have the definition of a pod. We have the metadata for the pod, consisting of our labels. We have the specification of the pod, service count, node selector, volumes, and a container and container configurations. So what's new here? First is replicas. Before, we can only deploy one pod. Now, we have the ability to deploy as many as we want. Here, we're deploying two, but this will allow us to scale the application. Next, we have selectors. There, we see match labels. So what's that used for? The selector match labels are a component used to determine the pods that belong to the replica set. For this to work, any label under match labels must also be set on the metadata labels section in the pod template. You'll see that over here. Then, the pods that match those labels need to have the owner ref set to the right replica set. Pods that are created by the replica set will automatically have the correct owner ref set for us by default. Now, with replica sets, we now have the ability to delete a pod and have it come back. Let's deploy out our replica set. We see we have two pods. Let's delete one. Now, let's see how many pods we have. And there we go. We have a new pod. If you remember from our first video, when we deleted an individual pod, it didn't come back. It was just gone. Here, we got our pod back. And as you can see, we still have two running. Now, why would I want to introduce a deployment? Let's try to update our replica set. To diff. We see the change. Let's apply it. Notice nothing happened. Let's check out a pod. Still says the keys. Our change hasn't been propagated. How can we get our change to propagate using a replica set? Well, we'll have to delete the pod. We see we have a new pod. And now we have our environment variable set up properly. However, the other pod also hasn't been changed, which now means if we describe this other pod, we're in a situation where only half of our deployment has the new environment variable and the other piece doesn't. I'd then have to continue deleting pods to be able to fix this issue. Right there is a huge limitation of replica sets. We have to manually propagate the changes that we've just made. Also, if there's ever an issue with the deployment, there isn't an easy way to roll back. We would then need to make the change to the replica set, redelete all the pods, and then the change would be propagated. So how do we solve for this? We solve for this with the deployment. Deployments manage replica sets for us. Anytime a change is put into the template section, a new replica set is created, and then how the pod changes get rolled out is managed by strategy. So in a type rolling update, the new replica set will be scaled up while the old replica set will be scaled down. With type recreate, the old replica set will be immediately scaled to 0, and the new replica set will start to be scaled up to the desired replica count. There's also one other piece here, this revision history limit. This is the total number of old replica sets that are kept. This is very useful because it allows us to be able to quickly roll back a deployment to a previous revision. So let's apply our deployment. Now we have our two pods. We see we have our replica set that our deployment is managing. We have our pods. Now let's update our deployment. We see the diff. Let's apply it. And there we see the rolling updated action, leaving the two healthy running pods up while we scale up the new one. The old ones are being scaled down. And now we see, if we take a look at our pods, we have keys specified here, which was our change. There we go. We see our keys have also propagated to the second pod. We can also use this command called rollout specify our deployment, and we see that our rollout was successful. You can also check the history of our rollout. And see that we have 2 revisions. As I mentioned earlier, because we have this history, we can roll back to a previous revision. So let's see how that works. Then we pass the revision. We can then get rollout status, see it's been rolled out. The old pods are terminating. Now let's check out the new pod that was just spun up. And perfect, we're back at the key. What would we do if we actually wanted to have communication between our apps? That's where the service comes in. On the bottom, we see our deployment that we're now familiar with. Up here, we have our service. So name, namespace, service labels. Here under our spec is the more interesting components. We have the selector, which is what's used by the service to determine what pods to route requests to. Over here, we have ports, where we specify our protocol, in this case TCP. And we have port, target port. The way to think about port and target port is what the service listens on. Target port is what the container listens on. If you omit target port, it'll be the same value as port. So it's not required for you to set this. So let's see this in action. We're going to be using a simple Ping-Pong application. Apply both. So we've deployed our 2 services, Ping service, Pong service. We have our 2 new deployments, Ping and Pong. What we should be seeing is requests going from Ping over to Pong. And that's what we see. What's actually going on once the service is deployed? We see here a few things. This is a cluster IP type service, so this is a service that's used to communicate within the cluster. This is the default type of service. We see the ports that we specified and the selector. Here we have an animation that'll show how the request will move from the Ping pod in the Ping deployment through the Pong service and be load balanced to the 2 Pong pods in the Pong deployment. Thank you for your time. If you like the content in this video, please like and subscribe.